what I'm going to discuss to you again is on the computations doon sa ating titrations. Okay? So again, what we cover only is the acid-base titration and only strong acids and strong bases. So in the first part of our experiment, what we did is prepare the sample. Balikan lang natin yan. So we have here the prepare the titrant, not the sample. So again, the titrant is very important kasi yun yung ating standard solution na gagamitin para mag-titrate ng ating unknown sample. Okay? So during the preparation of your titrant, ang kailangan lang natin dito na formula is your dilution formula. That's the formula there. Okay, you have your dilution with yeah, that's your dilution formula. So this one, okay, you're going to use this one. Take note, this is not A and B, this is 1 and 2. So 1 again represents your stock solution or the original solution. And then 2 represents your prepared solution. Hindi pwedeng magkabaliktad yan. Okay? So this is your prepared or your desired. Kung ano yung gusto mong i-prepare in a particular analytical procedure or titration procedure. So kunwari, you want to prepare 0.3 lang na titrant. So yung C2 mo hindi 0.25, pwedeng 0.23. Or baka yung ine-expect mo na ang sample mo maliit lang siya masyado. So kailangan yung iyong volume, for example, or yung concentration na gusto mong i-prepare, siguro nasa 0.01 normal. So depende yon sa demand ng iyong analysis. Depende sa gusto ni client or depende sa sa tingin ninyo kung ang inyong sample ba is nasa macro scale, nasa micro scale ba siya, or nasa nano scale ba, kung sobrang liit na nung yung iyong desired. Okay? So sa ating experiment naman, ang ating gagawin is we want to prepare 0.25 normal. This is our desired solution. The 0.25 normal solution. Okay. So what we did is we mixed your sa experiment pala hindi 0.25. I think our desired solution sa experiment is 0.125 lang. Dinivide natin yan siya into 2. Kasi para yung ating mass kasi ng ating unknown sample maliliit. So hindi 0.25. Nevertheless, this is still an example of your computation. Okay, so kunwari, this is our experiment. Prepare a 500 ml of 0.25 normal HCl solution from a concentrated solution. So this is our problem solving. So we know that the concentration of your acid, the concentration of your concentrated acid is 12 normal. Yan. So these are the common acids. HCl is 12 normal, and then your sulfuric acid naman is this one is 36 normal. Yun yung ating mga common na concentration ng concentrated acids. Okay? So, from concentrated, okay, ano ba yung ating concentrated solution dito? Is it our desired solution ba? Or that's our stock solution? Yung ating concentrated na acid.
Ang stock po, ma'am. Stock.
Okay, very good. Your concentrated is your stock solution. Okay, ang ating gagawin ngayon is we want to prepare, tama, that's the stock solution. Ang ating gagawin is we want to prepare 0.25. This is our desired solution. Okay, hindi natin pwedeng gamitin si CABA ha kasi walang base dito. Okay, pag dilution, we are talking of the same substance, hydrochloric acid solution to another hydrochloric acid solution. Ano lang ang difference? Concentration lang. Sodium hydroxide, for example, to another sodium hydroxide. So, paano ngayon pag binigay ko na problem solving, hindi na siya hydrochloric acid. Sodium hydroxide na siya. So, it's a base. Okay? So, again, this formula is for dilution. Okay. Now, our question here is that, paano natin, i-compute yung ating volume na kailangan. Okay, that's the V1. Yan yung kailangan natin na volume for our preparation. So here, again, ang gusto natin is we want to prepare 0.25. Okay. So, ang ating requirement is how much is the volume 1? Okay, how much of the stock solution are we going to use? Okay, we have here 10.42 yung ating volume na needed, okay, because from the formula, V1 is equal to C2 V2 over C1. And you will get that one. Okay, and then how are we going to prepare? Mix correctly 10.42 concentrated hydrochloric acid with distilled water in a volumetric flask. Remember that you have to pour acid to water and not water to acid. Ibig sabihin, when you're going to mix this one in your volumetric flask, so if this is your volumetric flask, napakita ko naman sa inyo yung volumetric flask last time, di ba? Okay, meron siyang long na neck, pero isa lang yung kanyang graduations. So kung 100 ml lang siya, isa lang yung graduations niya para lang talaga sa 100 ml. So you're going to place water first, konting water. Okay, huwag mo ubusin yung iyong 489.58. Okay, konting water lang para paglagay natin, okay, masunod natin yung concept na pour acid to water and not water to acid. Anong mangyayari ba kung ang ilalagay natin una is acid tapos lalagyan natin siya ng water? Ang mangyayari is that magkakaroon ng fumes. The hydrogen, the hydrochloric acid, magiging gas yung ating hydrogen chloride. So, pag gano'n ang mangyari, magkakaroon ngayon ng less concentration ng hydrochloric acid kaya nahimo man siyang gas ng uban. So kung nahimo na siyang gas, mabawasan na siya ang imuhang concentration. Okay, nag-evaporate naman itong uban na gas. In that case, dili na ito makuha ang atong right concentration during the preparation. Aside from that, safety precautions, those fumes can cause permanent lung damage. So yun yung iniiwasan natin. Okay, those fumes, imagine that's hydrochloric acid, that's acidic. So kung lalabas ng fumes during the preparation, maglalabas yan ng fumes during the preparation, tapos ma-inhale mo siya, magkakaroon nyo ngayon ng butas-butas yung iyong lungs. Okay, so that's the very, very, pinakaunang reason bakit hindi natin pwedeng, hindi pwede natin kalimutan yan. Okay? So that's the preparation. Okay, the next step that we did is we standardize. So kasi meron tayong, again, ang ating purpose ng standardization natin is kailangan natin makuha yung true concentration ng ating titrant. There are two ways to standardize. The first one is you have your direct method. Sa direct method, you don't undergo titration. All you have to do is measure accurately your mass of your solution, okay? And then dissolve that one in a very accurate apparatus, make the solution accurately. Okay, so for example, hindi pwedeng gamitin dito si beaker, hindi pwedeng gamitin dito si Erlenmeyer flask kasi ang laki ng error ng apparatus na yon. Pwede lang natin gamitin si volumetric flask at si pipette in doing our direct method. Okay? At the same time, hindi rin siya applicable sa lahat ng substance kasi for example, hydrochloric acid, hindi siya solid. So, unsaon mo na kapag measure ang atong hydrochloric acid in your analytical balance if that's the case. So, hindi talaga natin magagawa yung direct method. And when you're using hydrochloric acid. Sodium hydroxide, yes, pwede kasi sodium hydroxide is a pellet. So, pwede natin yung gawin ang direct method. Okay, but then again, most of our titrants, mas mabuti kung ang gagawin natin sa kanila is to do standardization. So, anong process yung standardization? Kailangan natin siyang i-titrate with a primary standard. So, we will do titration, pero dapat alam natin kung ano yung mass na ginamit natin sa ating primary standard to standardize our sample. Okay? Now, before doing the titration method, it's important that you know how to estimate kung gaano karaming mass ang iyong gagamitin during standardization. Okay? That particular assumption, that particular lab technique, that's the first thing that you should do. Here is you have to estimate the amount of primary standard. So, paano ba tayo mag-estimate nung amount ng primary standard at saka bakit natin kailangan i-estimate? So, kasi for example, wala kang plan na ginawa during the analysis, nag-measure lang ka sa imuhang mass of your sodium carbonate without being mindful. Ang mangyayari ngayon is that kung marami yung iyong na-measure na mass ng sodium carbonate, mauubos yung titrant mo, wala ka nang magagamit in your unknown sample. Basically, yun yung pinaka-importante, magagamit mo siya in your unknown sample. Pero during standardization pa lang, naubos na siya. Kasi ang mali yung mass na ginamit mo during the standardization. So, this is an important technique na kailangan ninyong gawin before you standardize. In our experiment, hindi nyo na ito ginawa kasi we already estimated the mass of sodium carbonate na gagamitin natin during the titration. Okay? So, for example, ang needed natin na concentration is 0.25 lang. Okay, pagkatapos, gusto mo hindi maubos yung iyong 500 ml na na-prepare sa standardization kasi marami kang samples. So, kunwari, you estimated na dapat yung volume ng acid na magamit ko kailangan around 30 ml lang during standardization. Okay, so estimate mo yan, around 30 ml. So, in that case, you can now use the formula. Okay, CABA is equal to mass of your base over your molecular weight of the base per replaceable hydroxide. Concentration ng ating titrant is equal to 0.25 normal. Ang volume natin na gusto nating magamit is only 30 ml. So, from our formula, okay, our estimated mass is equal to, we have CABA times molecular weight per replaceable. Okay, CA is 0.25 equivalents per liter. Volume is 0.030 liters. That's 30 ml. And then we have here molecular weight. That's 106 grams per mole. And then replaceable is you have 2 equivalents per mole. Okay, cancel the mole, cancel the equivalents, cancel the liters, then we have the estimated mass. The answer is 0.3975. Okay? So, ito siya, hindi talaga ganon ang makukuha natin sa mass ng analytical balance. At least, around that mass. Okay? So, mga around, pwedeng 0.3, pwedeng 0.31, pwedeng 0.32. As long na hindi siya lalampas dito sa 0.39, hanggang 30 ml lang yung magagamit mo during your titration. Masisave mo yung mga volumes ng iyong titrant. Questions on this part? After the standardization procedure, okay, na-estimate na natin yung amount ng mass, okay, na gagamitin natin. So, the next thing that you should do now is standardize. We have an example here, kaya lang dito sa ating, I think sa example natin, ang gusto naman niya is 20 ml, yung gusto niya na volume. So, kung 20 ml yung gusto niya na volume, if you're going to compute that one, okay, ang mass naman niya is around 0.26. Okay, 0.26, so pwede 0.3, ayun, kung 20 ml, 0.26, kung lalampas dito, syempre lampas sa 20 ml yung volume na magagamit niya. Halos 0.3 lang naman yan, so okay lang yan siya. Okay, that's our estimated mass. So, in the standardization procedure, again, you do the titration. When you do the titration, syempre, you're going to get the volume of acid para makompute natin yung ating unknown variable. Ano nga yung ating unknown variable sa ating standardization? Anong hinahanap natin sa standardization? Sige. So, sa standardization, again, kailangan nga nating mag-standardize kasi nga kailangan nating makuha ang tamang concentration ng titrant. Ewan ko lang ba kung bakit hindi nyo yun nag-gets. Balik-balik na nating sinabi yan. Okay. So, here, we have the standardization procedure. Kunwari, tapos na tayo sa titration. Tapos na tayo sa titration, ngayon, nagkaroon na ng volume. Kaninong volume ito? Yung 21.3 from 0.5. That's the volume of the prepared hydrochloric acid. Okay, hindi pa yan yung true na concentration. Hindi pa natin siya masabing titrant kasi nga hindi pa tama yung kanyang concentration. So the prepared pa lang, yung na-prepare pa lang natin. So the prepared hydrochloric solution, hindi pa siya standard hydrochloric solution. Okay, merong dalawang doon kasi pag prepared, hindi pa tama yung concentration niya. Pag standard na siya, yun na talaga si titrant, tama na yung kanyang concentration. Okay, so how are we going to compute? We have here CAVA is equal to CBBB. This time, we use acid and base, the A and the B na. Okay, kasi this is already titration procedure. Iba ang acid, iba ang base. Okay, so from here, we have CA. Ito yung ating the true concentration of our titrant. Volume used. Okay, saan natin nakuha itong 0.020 liters na yan?
Minus po, ma'am, ang 21.3 sa 0.5 mga ml. Tapos, i-convert into liters.
So, where did we get the 0.20 liters? Take note that we did the titration and we used 21.3 as the final volume and 0.5 as the initial volume. So, you have to minus, ayan, nasa screen, 21.3 minus 0.5, the volume of your acid use is 20.8 ml. So you need to convert that to liters. And then we have here the equivalence of your base. So we use the formula. Take note that we have two, here, we have two formula. Si CBBB, that's the first formula for the moles or equivalents of the base. Gagamitin mo lang itong formula na ito pag naka-solution yung iyong yung iyong base. Okay, or yung either kung base ang iyong titrant, si acid. Basta naka-solution siya. Or pwede rin na you're going to use this formula. Okay, that's also equal to equivalence of the base, which is your mass over molecular weight of the base per replaceable. This is also equal to equivalence of the base. Now, when are you going to use this formula? When are you going to use this formula again? This is used when it is in a solution form. This is used naman when it is a pure solid. Kasi kung nakita niyo yung sa experiment natin, hindi naman siya nakadissolve, di ba, sa water. Kayo ang nag-dissolve nun sa water. Ang binigay sa inyo is a solid. So that's why you can use this formula. Okay. Pero pag ang binigay sa inyo is nakadissolve siya, it's a solution form, you use this one. Siyempre, ibibigay sa inyo yung concentration ng inyong base. Okay, kung naka-solution form siya. Okay, so our unknown here is the concentration of your acid. So by solving, the concentration of acid is 0.2435. That is now the true concentration of your acid. From our previous example, doon sa ating preparation, ano nga dapat? Ano dapat yung ating ano dapat yung concentration ng ating acid dito? Ano yung ating desired concentration? Ang ating desired concentration is, ayan o, 0.25 normal. That is the desired. Yun yung gusto natin na makuha. 0.25 normal of your titrate. Okay, pero ano yung nakuha natin dito sa ating standardization? Instead na 0.25, ang nakuha natin is you have 0.2435 lang. Okay, ibig sabihin yan, based on our target concentration, which is 0.25, after we standardize, we only get 0.2435 normal. So this means that the errors are really inherent in the preparation of our titrant. Ibig sabihin nun, merong error doon sa ating preparation ng ating hydrochloric acid. Okay. Obviously, kasi nga hindi naman tayo gumamit ng volumetric flask when we did the preparation. We only use the pipette, the graduated cylinder, and also your beaker to prepare your solution. Kaya nagkaroon ngayon ng some errors. So, that's the main reason why we have to standardize. Kasi if we will be using a non-standardized titrant, it will also follow that we will have errors in the concentration of our unknown. Madala niya yung error pagdating na natin doon sa unknown concentration. Okay? So this is your titration experiment. Okay? Sige, practice tayo. Question number 3. What is the reading? What is the initial reading? Question number 3. What is the initial reading in the burette? The correct reading is actually 9.65 or 60. I have seen mayroong nag-answer ng 9.62. Very good. Kasi nga, lampas siya ng 6. Okay? Kung titingnan ninyo, yung kanyang lower meniscus, hindi rin siya umabot ng 7. So, kung may nag-answer ng 65, 62, that's very good of you. Okay, but I will accept 9.6. Okay, so here we have burette. Ang gamit natin, how do we read burettes? Kailangan pababa yung reading natin. 9.1, 9.2, dito ang 10, 10.1, ganyan. Pababa yung reading natin. Okay, so for the final reading, so basically, hindi rin siya umabot ng 2, so this is 24.15. Around 1.5 yung ating final reading of the burette. Very good. It's 24.15. Okay. So for our case in the experiment, Okay, we use methyl orange. Maraming maraming titrations. Ang pinaka-common na ginagamit sa strong acid, strong base is phenolphthalein. But in our case, we use methyl orange as our indicator. So, ano yung color? That's a peach color yung ating end point. Okay, equivalence point again is different from end point. End point is yung makikita natin sa visible eye. Yung equivalence point is yung sa ating computations. Okay? Pag if it is acid, it's color yellow. Pag if it is a base, it's color yellow. If it's an acid, it's color orange. Okay, let's now go to our titration proper. Sa titration proper is meron na kayong unknown sample. Okay. So, kung meron na kayong unknown sample at saka meron na kayong standard na titrant, so ibig sabihin nun, expected na talagang tama yung makukuha natin na concentration ng ating unknown sample. Okay? Okay, let's have an example. So, here, we have an unknown sample. Okay, hindi sinabi kung ano na base. Okay, ang sinabi lang dito is concentration of the base. Okay, hindi sinabi again kung ano yung base na ginamit natin. But we use our standard, our titrant. Okay, that's 0.2435. Now, during the titration, 25 ml of your point was used to titrate a 50 ml. Okay, hindi na natin kailangan itong A- volume initial and volume final kasi sinabi na niya na 25.8 ml ang volume na nagamit. Okay? At ang ginamit naman natin is a 50 ml of your unknown sample. Dinisolve natin yung unknown sa 50 ml volume. Okay. Using our formula, we now get the concentration of your base into 0.1256. Okay. Paano natin nakuha yan? CB from here is equal to CA/VA divided by your BV. CA, yan yung concentration ng ating standard. VA, that's the volume of your acid used. And then the volume of your base used, that's your BV. And from the solving, you now get 0.256 normal of the base. Okay. What if there's a follow-up question? What is the mass of the base in the sample if unknown is sodium hydroxide? So, paano kung ang base natin is sodium hydroxide? Molecular weight of your sodium hydroxide is 40 grams per mole. You solve in your sheets for 15 minutes. So, sige daw, tingnan natin kung saan sa inyo ang may tamang answer. Okay, here, what you are given is already, meron na tayong normality. All you have to do is just convert your normality to your mass, di ba? Okay, take note na the formula of normality is equal to mass over molecular weight per replaceable, okay, over volume. Okay, kaninong volume nga ito? This is for your base, di ba? Okay. So, ang unknown natin ngayon is, ano yung hinahanap natin? Ang ating unknown is our mass. Ayan. So, if we're going to convert our formula, mass is equal to normality times molecular weight of your sodium hydroxide, replaceable ng sodium hydroxide times the volume of the base. Okay? So, here's your normality, 0.1256. Normality means equivalence per liter multiplied by molecular weight, which is 40 grams per mole. Ilang replaceable ang sodium hydroxide?
1 lang po, ma'am.
Very good, that's 1. So this is 1 equivalents per mole. Okay, mole. Tapos anong volume ng ating base? That's 50 ml. So that's 0.05. Maklaro ba? Yung volume ng base natin, multiply natin siya dyan. Multiply natin sa 0.05 liters. Cancel the liters. Cancel the equivalents. Cancel the moles. You're left with grams. So final answer is 0.2512. Final answer should be in 3 significant figures. So final answer should be 0.251. 0.251. Okay? Okay, kung ang question sa problem solving is mass ang hinahanap, okay, convert your formula para magiging mass yung unknown. Kung concentration, hanggang concentration lang siya, then you can give the concentration. Paano pag ang hiningi sa inyo, what is the concentration of your unknown sample in ppm? Do you know how to convert 1 units to another?
Yes, me, ma'am. Sa gani magagamit na volume?
50 ml. Volume of the base, dara. I erase this one. So that will be for your titration. We end up our first method, which is titration. Next method on quantitative analysis is your instrumentation.